So I just wanted to thank everybody that has been helping me. Of course, Andy, I'll introduce him more formally in a second. Robin Adams from PARE and New Hampshire Saves button-up coordinator has been doing flyers and all kinds of things for us. And then Chris Finnegan is the librarian here. So she helped me with the sign out the road. I don't know if anybody's seen it. And Wendy Byrne is here from Sullivan Conservation Commission. And then we have Nelson Clean Energy that's been helping me. And I want to thank Lisa, Max, and also Gordon Peary with announcements. Max was going to be helping with audio if we were in the town hall, but he still gets thanked because he always does all kinds of things for us. Nelson Clean Energy meets every month on the third Monday of the month, and we'd love to have more people come and join us. So it's 6 o'clock, library lower level. The website address for our website is on the bottom there. So all the stuff that I'm talking about is up on the website. Just reminding everybody that Cheshire Community Power, you can opt in, opt up for cleaner energy. The telephone number's there. All you need is your Eversource number and call them up and they can help you. And then Rewiring America is doing a training, and I am taking that training to become an energy coach, more to help other people in town who are more technical become energy coaches. So we're going to be talking more about Rewiring America later on, probably in the fall. We'll bring Dory Drachman here and people from Prep in Peterborough. And just stuff going on in April is all up on the Monadnock Sustainability Hub's website. We showed the story of plastic here in Nelson, and somebody got so excited that now it's being shown at the movie theater in Peterborough on April 12th. And there's the Earth Fest and a Drive Electric Expo at the Monadnock Co-op on April 20th. And then Peterborough is going to be doing this same presentation with Andy. Maybe you'll get to meet him in person if you want to go to Peterborough, and they're going to be doing a hybrid. We want to welcome Andy Duncan. He holds a doctorate in environmental policy and behavior from the University of Michigan, and he's an adjunct professor at Lakes Region Community College and serves as their energy training coordinator. And he's also the principal at Foster Sustainable Energy LLC, and he holds several licenses from the Building Performance Institute. So we are really fortunate to have him here. So thank you very much.
Thank you, Patsy. And thanks for coming out on this snowy evening. And like I mentioned, we're recording this presentation, and I'll make the link of the recording available to Patsy to distribute. And also I want to mention that Phil Amaro is with us, and he is with Eversource Energy Efficiency. So if you've got any specific questions for him, he'll be around at the end, as will I, if you've got kind of a longer question, or you could shoot him a chat in Zoom. And generally speaking, if you've got questions as we kind of go through the presentation, feel free to put them in chat, but kind of the longer questions, maybe about your home or specific situations, we're going to save that to the end of the presentation. So this is all about improving the energy efficiency of your home. It's sponsored by the New Hampshire Saves utility, which is a consortium of Eversource and Liberty, New Hampshire Electric Co-op, and Unitil. My assumption is that most of you folks have Eversource Electric as your distribution utility. And so for the most part, all the things that I'm mentioning are going to be relevant for all four utilities. There's also natural gas that's in pretty much another part of the state, or a little bit in Keene. So a few things I'll mention about that. But the New Hampshire Saves program is pretty consistent across all those utilities. So there's a few things that they do a little bit differently. And there's one program in particular, Home Energy Performance Light, that I'll try to mention when we get to that point towards the end of the slides. And here's kind of what we're going to cover, kind of some quick tips to begin with, and then insulation and air sealing, the ABCs there, and what to do. Big focus with this presentation on the building envelope. In other words, insulation and air sealing around the boundary of your house. But we'll talk a little bit about heating and cooling systems as well. and certainly talk about New Hampshire Saves programs. Hooray, the Plymouth Area Renewable Energy Initiative. Um, and it looks like Robin Adams with Hooray is with us tonight, so that's great to see. They have a PDF of the presentation available. So if you just do a web search for Hooray and button up, that should get you there. If you want me to put the link in chat, let me know. And gonna keep on going here. So, a question for you folks, and you can turn on your mic if you want to answer this, and that is, what is the greenest energy? So, thinking about all the different types of energy sources and whatnot, what's the greenest of them all? Oh, I think Lisa is she's a ringer here. So she got it right. The energy that you don't use, or negawatts, came from Amory Lovins coined that term many decades ago. So really what we're going to be talking about tonight isn't so much solar or wind or other things, but it's more energy efficiency or the energy that you don't use. And we could be talking a little bit about frugality as well. But the kind of emphasis here is in kind of getting more energy bang for your energy buck. In other words, getting the most energy efficiency out of the way that you use energy. And we certainly use a lot of energy. Typical household in New Hampshire spending over $3,000 for energy costs, and a good chunk of that, probably the biggest slice of the pie, is space heating. So, day like today, got to stay warm, mid 30s outside or even below freezing. Water heating is another good sized chunk. Refrigerators, big enough slice of the pie to deserve its own chunk. Air conditioning is getting bigger and bigger. And then there's kind of everything else. And we are kind of one of the more expensive energy states in terms of the cost of energy. We're actually not so bad in terms of that's kind of the cost per unit. We're actually not as bad as some states in that we don't spend as much electricity on air conditioning as many, say, southern states. But because the cost of electricity, cost of things like heating oil, propane is quite expensive, that makes us a fairly expensive energy state. So, one of the things that I recommend is taking a close look at your electric bills and your other bills. And if you can, if your utility offers the ability to sign up with your account online, oftentimes you can get even more information online about electrical consumption. And keep in mind that the four electric utilities, they're the ones who keep the power going on days like today, go and fix the lines and repair the poles that have knocked over. You can work with the independent supplier, and there are for-profit independent suppliers out there. There's also more and more community power efforts at the municipal level. I'm not a big fan of the for-profit independent suppliers, and they actually just did a study in Massachusetts that shows that for a lot of those, people were actually overall getting a poorer deal than the default service that the four utilities offer. But community power is a great initiative, and sounds like that's really coming on strong in your part of New Hampshire. So one of the things you want to look at with that electric bill is how many kilowatt hours of electricity you're using. And typically, varies a whole lot from household to household, but somewhere on the order of about 7,000 kilowatt hours is a typical annual consumption of electricity. And that equates to about 20 kilowatt hours a day. And a kilowatt hour is kind of like the name sounds. It is essentially 1,000 watts of electricity that's on for an hour, for 60 minutes. So, you could have a 60-watt light bulb, and if it's not on, it's not using any electricity. So think of kind of 10 100-watt light bulbs on for an hour, and that's a kilowatt hour of electricity. So thinking about, where does all that electricity go? And this is just some rough numbers for a typical household. If you don't use electricity to heat your hot water, the domestic hot water, then you probably wouldn't have that big electrical consumption. That can be quite big. So households that do heat with electricity for their hot water, they're going to have a larger electric bill than households that don't, that use heating oil or propane or something else. Refrigerators and freezers can use a lot of electricity, kind of varies a lot depending on how old it is. And then some of these other ones I'll also talk about some more in terms of kind of opportunities. A dehumidifier, I think a lot of people don't realize that that's kind of like a air conditioner that you might have in the basement, dehumidifying the basement. And that can use quite a lot of electricity. So the stars on the right there give you a little bit of an idea of where might be the bigger potentials for saving electricity. We used to have 3 stars for lighting, but now so many people have LED light bulbs that that potential for saving more electricity isn't quite as much as it used to be. But they're also spending a lot less money, a lot less electricity for their lighting with the LED compared to the older style. And I'll talk about that in just a minute. So again, if there's something, that you want me to stop and explain a little bit more or have a question about, feel free to put that in the chat. So one approach with figuring out how much electricity different devices are using, particularly if they're plug-in devices, is using a watt meter, and there are different ones that are available out there. And Patsy or anybody, do you happen to know whether the Nelson Library has these available to loan out, just same way as kind of borrowing a book?
I do not know. Lisa, how about you?
Yeah, definitely used to a couple of years ago. So I imagine they still do.
Okay, I
Yeah,
will.
this is a program from almost 15 years ago now, where they gave all the public libraries in the state one or two of these things to loan out, and they still should be working. If you don't have one, you might want to encourage the library to purchase one. The less expensive ones are only about $25 or $30, and you can plug it in. And then, one of the things with a lot of electrical uses is that when it's on, it's on. When it's off, it's off. And it's sometimes kind of hard to tell, like, well, how much would I be using over the course of a year with something like a refrigerator that comes on, it goes off, goes through defrost cycles, things like that. So a lot of these watt meters have timers as well. So you can do a little bit of math. Some of them do the math for you, of kind of taking the consumption over a given period of time and turning that into an annual equivalent of kilowatt hours per year. And if you know what you're spending for a kilowatt hour of electricity, then that gives you a pretty good idea of how much it costs to run that appliance over the course of a year, or any device that's using electricity. So kind of a more sophisticated way of doing that is with these devices that connect to either the whole circuit board or individual circuits, and can tell you exactly how much electricity they're using. I've got one called a Sense, and I can tell you right now, including my computer that's on, I'm using about 322 watts. So if I stayed at this level, I would use about 1 kilowatt over the next 3 hours or so. But it's also being able to tell me, for example, um, essentially how much different devices are using. It uses actually artificial intelligence to kind of differentiate out different electricity consuming devices. It doesn't capture all of them, but it does a pretty good job with the big users. And so I found out, kind of to my surprise, that our electric kettle, we use more electricity with our electric kettle because we drink a lot of tea and coffee than our dishwasher uses. And it's a relatively new Energy Star efficient dishwasher. And that really surprised me. I thought, heating the hot water, running not super often, would use a lot more electricity than a kettle. So you can find out a lot. This is helpful also if you have, say, for some example, something like a well pump or a septic pump, where it's not a plug-in device and it's hard to figure out how much electricity it's using. Somebody who's handy with electricity, doesn't mind taking the panel off of the circuit, panel, the cover off the circuit panel, could install these themselves, but generally speaking, it would be safe to work with an electrician to install these because there's no real wiring involved, but it does involve high voltage, working in a high voltage environment that you would helpful to have an electrician. So kind of the simple version of all this is just to shut things off when they're not in use. But there's some things where even when they're off, they're still using electricity. And we call those phantom loads. And they're somewhat hard to tame because, anything, if you see something that has a light on, that means it's probably using a little bit of electricity, even if you don't have the device on. But there are what's called smart strips, and smart strips help control those phantom loads by having kind of a one outlet that is the master outlet, and it can control other outlets. So for example, if you've got a computer and it's got speakers with it, or it has an extra monitor, well, you don't really need that speaker on when the computer's not on. So the main computer would go in that master outlet, and those additional devices would go into the controlled outlets that would turn those other devices on when the computer comes on, and turn them off when it goes off. So it kind of helps control those phantom loads of electricity. And then, like I mentioned, LED lights. 10 years ago when we were doing button ups, we were kind of saying, yeah, they're kind of coming. And now they've been around for a while. They're very inexpensive. If you've got any lights that are still using 60 watts or so, and they're on for, at least a couple minutes on average a day, it would make sense to replace them. Obviously, the things that are on for hours a day would be even more important to replace. And there's all sorts of different types of light bulbs now. There's the small candelabra, there's holiday lights, there's outdoor lights. So it's worth kind of going after everything. And just keep in mind that there's different light colors. Um, a warm white is different than a kind of daylight bulb, and we're typically more used to that warm white, which is also called 2700 Kelvin. So you don't want to mix colors if you can help it. And you do have to take a look at things like dimmers, where they might have worked fine for an incandescent light bulb, but not for an LED. And things like enclosed fixtures in damp locations or outside, you have to be a little careful about LED light bulbs as well. So I'm not going to go into all details there, but if you have questions about that, feel free to put that in the chat or wait to the end. And then just some things to think about with that domestic hot water. That is, a pretty significant energy consumption area. So doing things like installing low flow shower heads and faucet aerators that kind of meter the water a little bit more carefully, that can actually save quite a bit on your domestic hot water energy costs. And installing hot water and heating pipe insulation, thicker the better, the more coverage the better. Great kind of do it yourself activity. And then you don't want to turn the hot water down too much, but turning it down where it's about 120 degrees, or you could just sort of barely stand the temperature of the water for a second or so when it comes out the tap, that's going to save more energy than having the water higher, and it's actually safer as well in terms of scalding. Don't want to get it too much lower than that because there's what's called Legionnaire's disease if the water's closer to like 90 degrees or 100 degrees or so. And then just washing clothes in cold water makes a lot of sense, pretty effective, and saves on that domestic hot water energy bill. So some other actions, other energy conservation tips. If you do have a dehumidifier in the basement, it probably shouldn't be operating now. Probably I'd say wait as long as you can. I've noticed that I've got one that operates a bit in our house, in our basement, and oftentimes I can wait until June, maybe even the beginning of July before I have to put it on. Other basements might not be that way, but generally speaking, it should be relatively dry in the basement in the wintertime, and you might not need to operate at all. So getting a little humidistat or a humidifier, not humidifier, but humidity gauge to see what sort of humidity level is in your basement or where you're operating the humidifier, or just kind of carefully turning down that humidifier so it's dehumidifying enough, but not too much. That can save a lot on the electricity costs of that. Line drying clothes outside if possible. We'll talk a little bit more about moisture sources and why line drying clothes inside, particularly in the summertime, might not be a real good idea. And then just purchasing Energy Star rated appliances. Those are the more efficient ones. And the New Hampshire Saves program will give you a little more incentive to purchase those Energy Star appliances. So that it varies a little bit on exactly kind of what tier of Energy Star they're at. There's the Energy Star most efficient, that is some of the higher rebates here. But things like electric clothes dryers, clothes washers, refrigerators, dehumidifiers, those all you can get rebates for purchasing the more efficient versions of those. And those forms are available online, or oftentimes at the stores where you purchase them. And there's a way to kind of fill it out online to make it easy. And then a program that I think is really great, that if you have, say, for example, a second refrigerator, or say a freezer in addition to your main fridge freezer, and you're really not using it for much, it's still functional, but you really don't need it, you can get it hauled away. They will environmentally handle the refrigerant in it, recycle it, and they will pay you $75 for doing that
Hi,
because they recognize, yeah.
so you just froze up. I don't know if that was us or it was me.
You know, how
I
is it
Yeah,
with
didn't,
I
everybody
didn't
else here?
I
I
didn't
didn't
see him
notice any
freezing.
freezing.
Yeah.
Okay, it must be
Yeah,
like, okay, okay, go ahead. Sorry.
yeah, but feel free to let me know if there's any sort of issues. So is it better now? It could be, if there's tree hits a power line or something like that. Um,
No, it's fine now.
okay, we'll cross our fingers here. Um, so Phil, do you happen to know about that program? There was a little bit of an issue last fall with the contractor that was doing that work. Are they all set now? Do you happen to know?
Unfortunately, I am still kind of getting back up to speed with utility programs. I believe the intent is to continue offering that utility buyback program, but I know I think the contractor might have actually gone out of business. Well,
Yeah,
I will look
there
into
was
that.
there was a bankruptcy involved. So it could be that if you call up the utility and said, "I've got a second refrigerator, it'd be great to get it hauled away," they might have to put you on a list, but it is still an existing program that they are interested and will eventually haul away your old refrigerator or freezer and give you $75.
Andy, can you check the waiting room again? Because we got a message that Wendy got a message that somebody's trying to get in.
Yeah, I'm not seeing anybody in the waiting room. I've got the list right here. So and I'm
Huh,
wondering if there's something else like with their Zoom connection or something like that. What
okay,
you could tell them is, to kind of close out and then come back in again or something like that. But I should be able to see them pretty readily
oh,
if they're in the waiting room.
okay, great, thank you.
Well, looks actually what I'm going to do is just turn off the waiting room. So that means they should be able to just go straight into it. I'm hoping that we're not going to get Zoom bombed tonight. It seems like an old term now, but if you remember about 4 years ago when COVID just started coming around, that was an issue with all these Zoom meetings that we had. All right, we'll keep on going here.
Yeah, yeah,
So,
please.
yep, all good. So I want to kind of move away from these sort of quick tips, things that you can do, to talking about staying warm in your home. I know we're kind of looking forward to when the snow all melts and spring flowers come out, and also timing's not perfect. This would be better said in October or November, but we do live in a what we call heating dominated climate. In other words, we do spend a lot of money and use a lot of energy to stay warm over the course of the year. So actually summertime is a great time to be kind of fixing all those things so that next winter you'll be more warm and comfortable and save energy. And, it's not just about turning down the thermostat. It's not just about freezing in the dark. It's having a house that is efficient and also very comfortable to live in. And that's probably one of the biggest things that I hear from people who have gotten kind of weatherization retrofit projects. They're like, wow, I'm amazed how much less drafty my house is and how much more comfortable it is to live in. So, it's not just about saving energy and reducing carbon impacts, but it's also about having a house that you enjoy living in. So a couple quick tips in terms of using less heat. So things like turning down the thermostat when you're not in the room or the house, or kind of the more automated way of doing that is using a programmable or smart thermostat that kind of help you with that. And then timing's not great. This should have happened maybe last November, but having an air conditioner through the window all winter long is you're probably gonna be losing quite a bit of heat out of cracks associated with that semi-open window. And then just having storm windows that are functional, latching windows. Those are kind of things that, again, better things to do in November, but just kind of good tips to remember in terms of kind of keeping your house snug and warm in the wintertime. And we're going to talk a little bit about kind of different ways that heat escapes out of a house. And it's not just out of the upper portions of the house, although that is a big chunk of where that heat escapes. But it's kind of all around the building shell to the outdoors. And our goal is to slow that process down. A sign of a well weatherized house is a house where you can turn off the heat or turn down the thermostat, and it only on a cold day, it only very slowly gets more cold. If you turn off the heat and you notice it 5 minutes later, and it's 20 degrees outside, that's kind of giving you a sign that there might be some opportunities for air sealing and insulation. So along those lines, heat moves, or we lose heat from that warm house, that expensive air that we have, that's the warm air in the house, through three different mechanisms: conduction and convection and radiation. I'm not going to talk as much about radiation because that's actually a major factor why houses warm up in the summertime. And so if that is an issue for your house, you might want to think about shades or shade trees around your house so you don't have as much of that radiation from the sun. And that's what we typically mean with radiation. But it's basically kind of a line of sight from um, something that's hot to something that's less hot. But conduction and convection, I am going to spend a little bit more time on. And first, going to talk about conduction, and that's the movement of heat through materials. Just a second. So think about if you've got, say, a basement and it has brick wall or even concrete or stone. Those are very thermally conductive. In other words, heat moves very readily through those masonry, stone, concrete materials. Or you can think about, if you had a piece of metal and put it in a candle flame, probably not a great idea to be holding that piece of metal because that metal is so thermally conductive. So we want to slow that down, and we slow that down with insulation or insulating materials. And there's all sorts of things that can be insulating materials. This is the kind of always think of like an interesting retirement project would be the Museum of Bizarre Insulating Materials. And so here's a couple examples. Over on the left is seaweed that was used as insulation near the seacoast. Balsam wool, guaranteed insulation, standard thick. So in the 1950s, standard thick insulation was about 1 inch thick. Well, we've learned that's probably not enough. And then over on the right were old rags that were used as insulation in an older house. So these are, somewhat effective, but we certainly have some more modern materials that are more effective than that. And if we were doing this in person, I'd kind of pass around some of these materials. We measure the effectiveness of insulation by R values. And so a lot of these R values that I'm listing here are per inch. So fiberglass is kind of like the name implies. It's like kind of usually a batt material, but it also can be loose. And it's just these kind of real spun, very fine glass fibers where it's not the glass that's insulating, it's the fact that they trap little air pockets, and it's the air pockets that are insulating. Cellulose is basically ground up newsprint, and it's the same idea. It's not the wood in the newsprint that's insulating, it's all the kind of fluffiness in the air that is trapped that makes it insulating. And then there's different types of foam board and spray foam. Some of them have special types of gases in them that make them more insulating than air. Wood is not a particularly good insulator. You can kind of compare its R value per inch to some of these standard insulating materials, and it's not impressive. And then for a whole double pane window, so we're not talking about per inch, we're talking about kind of the whole assembly. It's about a R 3.5, so it's about the same as 1 inch of fiberglass or cellulose. But in a typical wall these days, we're talking about 5 inches or more fiberglass or cellulose. So you have to kind of think about a window, except when the sun's shining in and you're getting some solar thermal gain, that for the most part, a window, even a really good window, is a thermal weak link in your house, particularly at night. Um, and it's just even a really good windows, maybe about a R5 or so. And that's just not anywhere close of what a well insulated wall assembly right next to it would be. So great, if you've got single pane windows and you replace them with better windows, but you have to kind of be thinking about windows as more as those thermal weak links rather than insulating in the same way that maybe the rest of your building envelope is. And then, just like I mentioned, that concrete wall, 8 inches of concrete, that has an R value of a little bit over R1. It has a lot of thermal mass, so it can hold a lot of heat, but it actually moves a lot of that heat through conduction from the warm inside to outside. So that can be very problematic if you, for example, have a concrete or stone basement foundation and it's not insulated. And then the blurb over on the left, just want to point out that it's a lot more than just what the R value is on the package. It's how well it's installed. And so certainly the devil's in the details with installation quality and how insulation is installed. And I'm not going to go over, I don't want to throw too many numbers at you, but basically this slide shows that a lot of houses have less insulation than they should. New Hampshire Energy Code stipulates the R values. If there's a good building inspector, they would inspect the quality of insulation, but even a fair amount of brand new homes might not even have those as functional R values. And certainly a lot of older homes, even homes from 20 years ago, 30 years ago, 10 years ago, might have quite less insulation than they should. So there's a lot of potential to make our homes better insulating and more comfortable. So here, kind of along the lines of that install quality, let's just say you're looking up in the attic and you see R38, which is a fair amount of insulation. That would be like 11 inches of fiberglass or cellulose. But then you see some kind of gaps, particularly if it's a batt insulation where there might be little gaps, or maybe there's an area where there's an attic hatch or a bath fan where there's no insulation covering it. So only 5% of the area is gaps, and that you're kind of looking down to the drywall that separates the heated part of the house to the attic. What's the average R value in a situation like that? So it's basically 95% R38 and 5% R1, which is about the insulating value of drywall. Anybody want to take a venture of a guess there?
Down to
Yeah,
25.
We have an R10 from the audience here.
R10, R25. Good guesstimates. Yeah, the person who said R10 is actually very close. So
Hey,
even though 95% of it is R38 and only 5% is R1, you can't really average R values. So it's really about R13. There's basically more conductive heat loss from that 5% of the area that's uninsulated than the whole 95% of the area that is well insulated. And so again, that's where the install quality makes such a big difference. So thermal barriers, those insulating barriers can be insufficient, not enough R value. They can be incomplete, so low R value in spots. You can see in the middle of that middle photograph, and then missing. And so what you're seeing with that kind of red outlined rectangle on the right photograph is basically where there should be insulation in that wall. This is the back side of a wall, and there is that pink insulation below that rectangle, but the installer just missed whole areas in the joist cavity where that rectangle is. And that for vertical walls, that's actually fairly common, unfortunately. So, a question for you, particularly related to conductive heat loss. Heat rises, true or false? Anybody want to venture an answer there?
true.
It's like you kind of get credit for it. It's sort of true, but when we're thinking about conductive heat loss, we have to be thinking that basically heat can move in any direction through materials. So one of the most uncomfortable types of buildings, houses in New Hampshire would be a concrete floor on grade, where basically there's all sorts of conductive heat loss through that concrete to outside. So that conductive heat loss is going down in that example. But you get credit for the fact that warm air is more buoyant, and so the heat in that warm air does rise. Not that we have a hot air balloon in our houses, but it's kind of like that happening. And so that kind of gets us into the uh, the next section where we're talking about convective heat loss. And so it's a really important concept that people don't understand that well. They kind of think, all right, I just need to insulate my house and then I'm going to be all set. And what I like to tell people is they really kind of need to have like these two different nodes in their brain. And one of them is conductive heat loss that they fix with insulation. And then the other node is convective heat loss, or basically air leakage that they fix with air sealing. And the reason why we have air leakage in a house is because of slight pressure differences. The colder it is, the stronger those pressure differences, and also the more stories in a building, two-story house is going to have a stronger effect we call the stack effect, that's from convection than a one-story house. And so typically in the wintertime, even a day like today, there's going to be cold air leaking inside, typically kind of basement area. And that might be a little bit more noticeable, but then there's warm air that's leaking out from the heated part of the area to the rest of the house, into the attic or directly to outside. And that's the part we don't tend to notice very much. We may notice other kind of convective currents inside a house, like if you had a wood stove where there's warm air that's kind of rising right near that hot wood stove, and then it gets close to the outside wall, particularly those windows that aren't all that insulating, and it gets cooled, and so therefore it falls, and you have these loops that can happen inside a house. So if you want to be a real energy geek, go around with like a piece of tissue paper or toilet paper and check out like the top of the bottom of the stairs, down low and up high, or in doorways, particularly between kind of colder and warmer areas of the house. And you'll notice, particularly on a fairly cold winter day, that there'll be these kind of subtle currents inside a house. So that's one thing. The thing that's more important in terms of heat loss is that expensive air that's warm that is leaking out of the house. And there's a fair amount of houses, in the Nelson area and elsewhere that are losing more heat from air leakage than they're losing from lack of insulation. And people just don't realize it. They're like, oh, yeah, I live in an old drafty house. But they don't realize that they really need to go after that air leakage with air sealant to fix it. And in terms of going after that air leakage, um, a good way to think about it, it also holds true a little bit for insulation as well, but particularly for air leakage, is A, B, and C. So, in other words, highest priority is that boundary between the living area and the attic. And then the second highest priority is B down in the basement. And then the center of the house is kind of a lower priority. So, kind of go into a little more detail there. And so the thing is, a lot of people are not crawling around in their attic and they don't know about things that are happening. And so here's a couple photographs of examples of air leakage in the attic. So you'll notice in some of these photographs that the pink insulation is stained dark. Well, that is dust that is caught by the air leakage that's happening in holes and cracks and whatnot. And then the middle photograph is a chimney chase, and it might not look all that big, but to me, that 1 inch, 2 inch gap between the chimney and the rest of the attic, that's like a super highway for air leakage. That's a lot of air leakage happening there. So even a 1/8 of an inch crack is of concern and probably should be sealed because we're talking about pressure differences. We're not talking about covering a surface area. We're talking about because of pressure differences, warm air leaking into the attic. And so there's a lot of opportunities. The folks who are good at this are going to be using a blower door to measure the air leakage, and then they're going to be going up and they're going to be moving away whatever insulation is up there, getting to that base of the attic floor and sealing that attic floor with usually a kind of a foam type material. And I'll have some more slides with that in just a little bit. So another question for you. This is kind of combining conductive and convective heat loss. So if you had 16 inches of fiberglass insulation and it was on top of this pegboard attic hatch, is that a good assembly? Yes or no? You might want to venture an answer.
We're stumped in the audience here.
So the 16 inches of
We think
insulation is
no.
certainly good. Certainly good, but there's a but here, and that is all those holes with that pegboard ag hatch means a lot of air leakage. And so, you could think of those two different nodes in your brain. It's like, yep, pretty good with insulation, but not so good with the air sealing. And you got to be able to do both. And the problem is a lot of this kind of fluffy, fibrous insulation really doesn't, you could put it in, but it doesn't necessarily stop air leakage. So you have to be thinking, all right, what should I do to stop the air leakage? And in this case, it would be a sturdy plywood attic hatch with a good weather stripping and then good insulation on top. Oftentimes it's like 6 inches of foam board or something like that that's kind of permanently attached to the attic hatch. And then just one thing to let you know about, I'm not going to go into detail here, but when we have this air leakage that goes into an attic, it's not just the air itself, it's also humidity that is associated with that air. And if there's enough of that, or if the house, say, for example, has a humidifier in the wintertime, uh, that you can have this condition like this, where, excuse me, there's condensation that happens on the underside of the roof. And then that would be like at nighttime when it's cold. And then a month like March or April, where it warms up again in the daytime, it's warm enough to cause mold growth with all that condensation. So, kind of a complicated concept there. But unfortunately, there have been a number of homes where somebody looks at this and goes, oh my goodness, we need to replace our roof because it's leaking. And the leaking's not happening at the roof level. The leak is happening with air leaks and the humidity associated with it. So want to move from the A to the B of the A, B, and C. So just a couple examples down in the basement. Any place where you can see daylight in a basement, that is giving you indication that there's probably some air leakages happening. And you will be able to notice it, particularly on a cold day, of that cold air coming in. I would say that air leakage is also a pretty common culprit in why people have frozen pipes, because they might think, oh, this pipe is 6 feet, 6 inches in from the wall, no problem. But if it's right by a crack where there's 0 degree air coming in on a really cold day, that could be cold enough to help freeze that pipe. So doing that air sealing in the basement can help quite a bit with frozen pipe issues, as well as, the more that you air seal either down below or above, the more that you're keeping that nice warm air in the house and not having it escape out. So one common area where there's air leakage is where basically the framed part of the house meets the foundation. So that's called the rim joist or sill plate area, box sill. And that's that diagram on the right there of the slide. So there's certainly ways to go about that. In the center of the house, there are some opportunities. Really, a lot of windows are not as leaky as people think. What happens is those convective currents tend to create maybe an internal draft, not cold air coming in, but air that is warm and gets cooled near the window. And people think their windows are drafty when really it's an internal air current. But a pretty subtle and can be a very big source of air leakage, particularly in older houses, is old fireplaces that don't have good dampers, and there's just a lot of warm air that just escapes up very subtly through that fireplace chimney. There are some fireplaces that are so inefficient that you could have a fire going in them, and they have less than 0% efficiency because there's more air escaping up the chimney than there is heat being produced by the fire. So something to keep in mind. Wood stove, particularly a good quality wood stove, it's going to be a lot different and a lot more efficient in burning wood than an old-fashioned fireplace. So there also might be some exterior doors that, if you can see daylight, things like that, or around this exterior door, where there might be opportunities for air sealing as well. So we're kind of in that convection heat loss, which is really air leakage. And a lot of people think, okay, well, houses need to breathe. Really don't want to air seal my house because, I like having all that fresh air. Well, there's a lot of homes, particularly say like an older farmhouse or something like that, where they're just way, way more leaky than they should be. And really the way to test the house is with a blower door, where you can take a look at the volume of the house, and there's some standards, and you can basically say, here's where your house sits compared to the standard. There's also standards for new construction as well. Um, so yes, we need fresh air, but we don't need just the equivalent of like an open window, which is a lot of houses are like that. They have so much air leakage. It's the same as having a completely open window all winter long. The other thing that's a factor with all that air leakage is that the air that's leaking in, that's replacing the warm air leaking out, is very, very dry. It has very low humidity. And so it can make houses kind of nosebleed dry in the wintertime if there's a lot of air leakage. And so the phrase that we like to use is seal tight and mechanically ventilate right. In other words, control the amount of air leakage with air sealing, and then meter in the appropriate amount of fresh air, and then provide exhaust ventilation in places like bathrooms and kitchens where we want to control humidity or odors and things like that. And there's all sorts of ways to control that ventilation. I'm not going to go into detail there. There's even things like heat recovery ventilators that use a heat exchanger to preheat incoming fresh air from the stale exhaust air that's going out. So there's a lot of different approaches, and a good energy auditor, energy professional is going to be familiar with mechanical ventilation and the standards and things like that. Certainly, if you have a bath fan or something like that, exhaust ventilation, You want to make sure it goes all the way to outside, and you want to have that exhaust ventilation ductwork insulated. What you're seeing with that little green arrow on the lower right is actually a chunk of ice, that there was all this condensation on the inside of a bathroom fan. It broke the flexible ducting, and it was a chunk of ice in the wintertime that was kind of hanging out from it. And if you look carefully with that lower left photograph, you'll see kind of a dark area on the underside of the roof. That is moisture staining from the bathroom fan that was kind of loading moisture in the attic. Not a good sign. And along the lines of that, this is kind of a disaster of a basement for multiple reasons. There's condensation on the other side, the living side of the plastic that's in the roof there. There's standing water. There's all sorts of issues. So hopefully you don't have a basement like that. But there's a lot of crawl spaces out there that have dirt floors, and that's a fairly easy fix to reduce moisture loading in a house by covering up that dirt floor with heavy duty plastic. And like I mentioned, bath fans and kitchen fans. I say that sign of a good energy auditor is that they're paying very close attention to moisture issues in the house. And a lot of those moisture issues are associated with humidity. It's not necessarily the visible moisture, but kind of the more invisible moisture. Don't have time to spend a lot on that, but if people have questions about their house and moisture at the end, glad to take your questions. So here's kind of a review question for you with this section. And that is, those are some pretty serious ice dams with that house, antique Cape style house. What do you think is the biggest factor, radiation, convection, or conduction, that is causing all those ice dams? Don't everybody shout out at once.
We're thinking convection.
You're right. So basically, there was insulation in the attic here, but there was basically no real air barrier between the living part, the heated part of the house, and the attic. So a lot of warm air got up into that attic. It melted the snow, and it just kept on doing that all winter long. And anytime you have icicles, I'd say longer than maybe 2 feet, with a house, 1.5 feet, 2 feet, you should be worried about where is that water going, because it can make its way actually into the exterior wall of the house. So these are at the level of like damaging ice dams that you're seeing with the picture there. So is this how we fix it? We just put roof melt tablets, salt tablets up on the roof? No, probably not the best idea. And some people find it a little bit incredulous, but I think a really good house is a house on a snowy winter day that has 2 feet, 3 feet of snow sitting on the roof. Now, not every house is built to current standards that should be able to handle that much snow, but a good house is a house that doesn't have icicles and has a nice, good insulating layer of snow, and there's not much in the way of ice dams that are happening. So you really shouldn't have to shovel a house if it's built to good structural standards. But if it's a house that you're unsure about the structural code with it, things like that, that might be a reason. But there's probably a lot more shoveling of snow off houses than really is necessary, particularly if it's well weatherized. So how do we kind of go about some of these things? Well, first we air seal the attic plane, and then we add a bunch of insulation. And so that's what you're seeing over on the right, kind of this big envelope of insulation after air sealing was done. And in terms of examples of air sealing beyond what I've already showed you, there's things like over on the left, where we're going after that superhighway with the chimney chase, fire rated materials. This over on the right is what's called a skim coat of spray foam. So it kind of envelops the whole area in terms of making sure that there's no air leakage that's taking place at that attic plane. Don't always have to do that, but that can be effective in certain situations. And then there's the whole issue of floored storage space in the attic, as well as attic hatches and pull down stairs. So doing what's called like a thermodome, which is kind of like an open box with weather stripping, can be very effective with pull down stairs. You're seeing an example in that middle top photograph of an attic hatch with foam board insulation on it, and then what's called the insulation dam between the kind of storage area versus the rest of the attic. And sometimes you have to make compromises. Ideally, the whole attic would have that amount of thickness of insulation. So not quite as much R value in the storage area as other parts of the attic, but there's at least a decent amount of insulation under the plywood storage area. And then there's a lot of Cape style houses or kind of story and a half houses in New Hampshire. So they have these triangular knee walls beyond the living area. And a lot of those just are not functioning very well. A lot of ice dams associated with Cape style houses. Probably the more effective way of dealing with that is to bring that air and thermal boundary, thinking about air sealing as well as insulation down the slope all the way to the eaves. And there's a couple different ways of doing that. Spray foam, or if it's rated for it, a certain type of foam board, Thermax brand can be done. But it should always be associated with making sure that it's not just the insulation, but also the air sealing is taking place. A very common problem with Cape style houses is warm air that leaks from that first to second floor joist cavity and leaks into the knee wall area. It causes ice dams and all sorts of problems. But it's not very noticeable either. It's something that you really kind of need to test with the blower door to measure that air leakage. Otherwise, it's sort of hard to figure that out. And then down in the basement could be something like putting in a good thermal and air barrier to going up to bulkhead or something like that. Down on the basement wall, that same Thermax brand can be effective for a basement that is not lived in, but you still have access to it. Not all foam boards would be allowable to be left exposed like that. And then the spray foam that you see in the middle photograph, that's going to have drywall covering it as a fire barrier. And then the kind of hard to see, but that kind of bulbous material is spray foam partway down a wall, and then it has an intumescent paint as a fire barrier over that spray foam. So any sort of foam materials that are left exposed, you want to be concerned about. Does it have the proper fire barrier? And then certainly you want to fix basement moisture water issues first before doing weatherization work down there. So one benefit of spray foam, say for example, that right photograph, is that it's helping to air seal that basement wall as well as insulate it. So that's very beneficial. And then in the middle of the house, the center, there are things like chimney flue blockers. So if you don't have a good damper with your fireplace and chimney, you can put that in temporarily, take it out when you have a fire. There's Q-Lon style weather stripping that goes on the outside of exterior doors. There's kind of uncommon is this photograph on the right, but it's an example of air sealing around exposed chimney chase in the middle of the house. And then particularly if the exterior walls don't have much insulation in them or don't have any, basically dense packing, typically cellulose insulation in those walls, will help insulate those walls. It's easy, relatively easy to do. You don't have to take the whole wall down. And it should be done by a professional because there's a certain technique with it. And it actually helps to air seal those walls because there can be a fair amount of air leakage associated with exterior walls as well. And then if you do have a furnace and ducted system, going after duct sealing with this goopy stuff called mastic, and then insulating. It's kind of the same idea as an attic where you first are doing duct sealing and then you insulate the duct afterwards. just like air sealing an attic floor and then adding insulation. So what about windows? Yeah, you could replace your older single pane windows with something that's like about a R4 or so. And that might cost 500, 800,000 dollars a window. For that same amount of money, replacing a bunch of windows, you could do a lot of weatherization work and save a lot more energy. So, maybe you want to replace windows for reasons other than energy savings, but we've kind of been duped to think that energy savings with window replacements is the big thing in a house, when really there's other more effective, cost-effective ways to get that energy bang for the buck. And then I'll mention the Window Dressers organization. It's a not-for-profit group, and they make these interior inserts that are custom fitted per window. And it's mostly with volunteer labor. So they actually are not very expensive, like 40 or 50 bucks for an insert. And they have what these called community builds, where they put these inserts together. So there was one in Keene. I don't know any of you folks in the Nelson Sullivan area heard about window dressers and looking into that at all?
Yes, I've
Yeah,
heard,
definitely. I heard about it. Yeah.
and I know there's
Yes.
one coming up. Is it in Pelham? I'd have to go look, but they're
I
doing,
think Peterborough might be working on one. It might be at the Max space where I'm teaching a building science principles course right now. So you might want to touch base with the folks in Peterborough and see if you can participate with it. But it's a very cost-effective way to get energy, better energy performance with Windows. But there's other approaches as well, cellular shades, window quilts, things like that. All right, are you overwhelmed enough here? I'm kind of moving from here's all the issues to talking about solutions a bit more. So hopefully that will be good. So one approach that can be very effective is getting an energy audit, energy assessment, where they're doing things like the blower door test. They're measuring the efficiency of heating units and combustion safety issues, looking at insulation levels, maybe checking things out with an infrared camera, and providing a written report with a prioritized list of cost-effective improvements. Sometimes it's even with the estimated energy savings of those improvements. And we'll talk in a little bit about the home energy performance program with NHSaves, where you can, in essence, get an energy audit for free, which is great. And things to look for with the energy auditor and finding a qualified energy professional. There's the Building Performance Institute. It's a not-for-profit best practices certification national group. And so the BPI building analyst is pretty widely recognized as an energy auditor certification. There's other certifications out there as well. And certainly you want to have an energy auditor do a blower door test. Infrared camera is important, but not completely necessary. Doing combustion safety, combustion efficiency tests, it's important too. You can look, I can show you, there's a way to kind of look to see who is qualified residential contractors who are working with New Hampshire Saves program, or that could be a question for Phil as well. There's also a not-for-profit group in New Hampshire called the New Hampshire Residential Energy Performance Association, and the members, myself and Phil and others are members of that group, and we're a best practices group, have monthly trainings. And so that's kind of a helpful sign too, if you're working with somebody who's a REPA member. So like I mentioned, a blower door is probably, in my opinion, the most important tool for doing associated with the energy assessment, in addition to somebody's eyes and ears and whatnot. But this kind of makes something that's very intangible a lot more tangible. It is a big exhaust fan that goes in the exterior of a door, and it measures the amount of air leakage. And you get a value in cubic feet per minute at a 50 Pascal pressure difference, which is sort of at the level kind of atmospheric weather type pressure differences, but it's enough to show where the air leakage is. And then you can determine how how leaky or how not so leaky a house is compared to standards. And then install crews use it as well when they do what's called blower door guided air sealing. So they turn it on the beginning of the day, see what the air leakage level is. You can feel where the air leaks are because of that pressure difference when the blower door is running. And then at the end of the day, they'll see how much they've achieved and see if there's other places that they still need to go after. And just a FYI, a new construction residential building, new house, a blower door tests are now required. It's not necessarily widely enforced, but that is state law. So another tool that's kind of nifty is the infrared camera. It's kind of got the gee whiz effect. You know, it's rather than a camera showing you a visual picture, it's giving a thermal picture. So the pixels are basically individual thermometers. So what you're looking at with those images there are a bunch of thermometers. You know, it could be like 10,000 thermometers. And so upper left, you're seeing with the purple, basically kind of a side wall with kind of a dormer area that's not insulated. The home in the upper right, there is one cavity that's more purple than the other, so a not well insulated cavity that is certainly not obvious at all just looking at it. And then the lower photograph is actually showing, I think on a summer day, air leakage coming in from the attic area that is quite warm. And so it's kind of causing this fan shape warm air that kind of go across the surface, and you see interesting image. So you can use a blower door and infrared camera together, and it can be very useful. So another thing that an energy auditor would do would be testing for combustion safety issues. And so, you know, what we don't want to see happen is backdrafting of flue gases into a house. And so they'll be testing for like ambient carbon monoxide levels as well as the carbon monoxide in the flue gases. And certainly you want to make sure that you've got, in addition to smoke detectors, carbon monoxide detectors in your house and make sure they're functioning. And then just in terms of heating systems in general, particularly say for oil, heating oil or wood, dirtier fuels, you want to make sure that they're well maintained on an annual basis. Don't need to quite as frequently for something like propane or natural gas. And seal and insulating the ductwork and making sure if you do have a furnace that the filters are changed regularly, usually several times over the heating system. And look for those energy efficient replacements, which I'll talk about in a little bit. And so there's a little bit of a fixation out there on like, well, you know, what I need to do is improve my heating system, make it more efficient, and then everything will be great. Well, you know, having a more efficient heating system in a building envelope that is not very efficient is sort of like having a high quality, efficient pump in a leaky bucket. You know, you're still leaking a lot of water, even though the pump might be pumping water very efficiently. So kind of going after that envelope first means that you don't need to have nearly as big a heating system, and it doesn't have to operate nearly as much. And so it's really kind of helpful to kind of think about priorities there, and building the envelope really should be the first priority. Just a quick example. This is a picture from Ted Stiles, energy auditor, where he was doing a blower door and he heard this big bang on the second floor, and it was a mirror that fell off the wall, and it was a kind of house that got flipped. And what they did is they took out the old medicine cabinet, and they didn't really kind of mess around with, didn't do enough air sealing. They put some insulation over it, but it really wasn't a good air barrier. And so there was enough air blowing through that old hole where the medicine cabinet was, to actually blow the mirror off the wall. So kind of a big find that otherwise would not have been found without a blower door. So I want to move into New Hampshire Saves programs and the different rebates and programs that they have. Definitely worth checking out the newhampshiresaves.com website or asking Phil any questions about any of these programs. Some of these we're just going to go through real quickly. I want to spend a little bit more time with the Home Energy Performance program. And with Eversource, they have a Home Energy Performance Lite program as well that I'll talk about that we don't have a slide on. So one is that there are a number of incentives, both New Hampshire Saves and then IRA stands for Inflation Reduction Act, some tax credits out there for things like cold climate heat pumps. Or if you do have natural gas, there's some good incentives for gas boilers and furnaces. Unfortunately, not available for propane. And then another one that I think is a bit of a sleeper topic, and that is heat pump electric hot water heaters. Very efficient, and there's really nice incentives both from New Hampshire Saves and the Inflation Reduction Act as a tax credit to get those. And then also not all that well known is if you buy a kind of more efficient EPA certified wood or pellet stove, there's a 30% tax credit that you can get, and that includes the installation costs. So something to think about if you've got an older wood stove or old fireplace or something like that. Wi-Fi smart thermostats as well. That's associated with electric heat pump heating or natural gas if people have that. And then a little bit about these cold climate heat pumps. You might hear them referred to as mini splits, and that's because they have an outdoor unit and an indoor unit, and basically refrigerant going between those two. So think of that indoor unit as really just like a heat exchanger on the wall with a blower. But you can also have a heat pump go right into a furnace type system as a replacement. What's not common yet, they're probably going to become more common, but what's called heat pump boilers or air to water heat pumps. Basically these heat pumps are using outside air to either take heat from or put heat into. And these days, you might have heard, oh, heat pumps don't work below 20 degrees or so. It's not true these days that the good cold climate models can still just kind of hum away at 10 degrees, 5 degrees, and they're still generating maybe not as much heat as they're generating at 20 degrees, but negative 20 degrees, they're still rated for generating a fair amount of heat. So, at that temperature, you probably want a backup source of heat. But a lot of these, we're kind of into the prime with them now, where they could be essentially your primary source of heat. You don't have to worry about having other sources of heat if you size the heat pump, cold climate heat pump correctly. And how they work is basically through the refrigeration cycle. So you think about how a refrigerator keeps things cool. It's just basically extracting heat out of the inside of that refrigerator, moving it to the outside. So the same way air conditioner works. And really the only difference between a refrigerator or air conditioner is that a heat pump can also operate in reverse. So kind of the weird concept to wrap your head around is that it's able to extract heat out of that 0-degree air and turn that into comfortable heat through the refrigeration cycle. Don't want to go into detail there because we don't have time for it, but suffice it to say, there's a lot of people who are very happy with their cold climate air source heat pumps out there. There's also what's called ground source heat pumps, and certainly worth looking into, but they tend to be a lot more expensive. They basically need to be tied to a water well in most examples. And so for most people, these air source heat pumps make more sense. And there are some incentives, they're not really big incentives for cold climate heat pumps. And I'll talk about the Inflation Reduction Act tax credits in a little bit with them. And there's some other programs coming down the pike that can make those heat pumps even less expensive. That's in addition to the New Hampshire Saves incentives. And like I mentioned, the heat pump hot water heaters, it's certainly worth looking into if you're using oil, propane, or resistive electric heat now for heating your domestic hot water, that the heat pump hot water is going to be more cost effective than any of those fuels. And there are programs for new homes, Energy Star certified new homes. There's a program that utilities have to encourage home builders to build homes that are net zero, which is kind of a neat concept. It's essentially that you have solar panels, heat pump hot water heaters, where over the course of 12 months, the solar electricity being produced offsets any of the other energy that's consumed in the house. And so it's a net zero home altogether. And we're kind of moving more and more towards net zero as kind of being the way to go. So the thing I want to mention with a little bit more detail is this home energy performance program. It's a really great program. Phil can give you more details about it too. You find out if you qualify for it by going online. I've got some screenshots, and you do what's called a home heating index calculation. If you do qualify, it costs $100 to get an energy audit. That's about a $400, $500 value. And actually, that $100 becomes a credit towards any work that's done. So the utilities will pay 75% of the cost of energy improvements up to a utility contribution of $6,000. And they'll can help with low or no interest financing for the part that you do have to pay. And programs that are, I mean, houses that are in really bad shape, you can potentially participate with this home energy performance program in more than 1 year. So you could do some work the first year. If it still qualifies with the home heating index, you could participate a second year as well. So we're checking out that New Hampshire Saves weatherization page, and it has more details about the program. And so when you get to that page, there's a little green box that says test your home. And what you need for that home heating index calculator is the amount of fuel, so like gallons of oil, gallons of propane, cords of wood, things like that, the heated conditioned square footage of your home, um, the who your utility distribution utility is, like Eversource, and your zip code. So relatively easy calculator to do. And you can go through it kind of on a casual basis. If you are going to participate in the program, they're going to need confirmation of how much fuel you use. So it could be like, a printout from your heating oil supplier, or it could even be photographs of your 2 cords of wood that you have ready to use for a year or something like that. If you have electric heat, you also need to input the monthly electric usage to get that calculated as well. But it's a fairly simple calculation. And in this example, it's a 2,000 square foot house in Laconia, New Hampshire, uses 800 gallons of heating oil and 2 full cords of wood. It gets a home heating index score of 9.04, I believe. And that means it qualifies, at least if it's in Eversource territory. So it is a little bit confusing. Like I said, for the most part, these New Hampshire Saves programs are pretty consistent across all 4 utilities. But this is one area where they differ a little bit in terms of the qualifying score to participate with home energy performance. The good news is if you're working with Eversource, they have one of the lower scores, which means more homes qualify. So only a score of 7 is needed to qualify. And that's actually lower than it has been in past years. So if you don't qualify and you are with Eversource, there's also this Home Energy Performance Lite, where you can still get some work done. And Phil, I don't know, maybe it might be good for you to explain that program, because it's a relatively new program and I'm still coming up to speed with it.
Sure. I'd be happy to, Andy. Thanks for letting me jump in here. The other thing I'll say, on the previous slide, you talked about financing, and the we do have financing available for the after rebate costs for the home energy performance program. At this point, we have all no interest financing. We had a low interest financing program available, and we've decided to make that no interest. So all of our financing is 0% interest. The differentiating factor is that up to $2,000, we have an on-bill financing program where you just pay your payment off on your electric bill. Above $2,000 to $15,000, we have a third-party subsidy agreement with local lenders, which allows us to, the lenders provide you with the financing, we just pay the interest for you. So thanks, Andy, for sliding back to that one. But with the home energy performance Lite program that we're working with, it's kind of an evolution of this option that we started a few years ago called the visual audit program. Some of the gas utilities are still doing these visual audits where contractors go in and install some highly cost-effective measures. The Home Performance Light program starts the same way, where one of our regular home performance contractors evaluates the home, and we will actually, there are several types of measures that we pay 100% of the cost of. So air sealing, pipe wrap, water heater setbacks, certain things like that. So what we've done is we've asked them to just go ahead and do that work, that any work they find that's available. We ask them to go ahead and just do as much air sealing as they can do while they're there. Do as much, pipe wrap as typically cost effective. And then while they're there, they're supposed to evaluate potential for insulating other measures. Typically things like the attic and the basement, at least the rim band. Look for air sealing and insulation opportunities, basement opportunities. The difference being that once they install those highly cost-effective measures, they can come back to the software we use and propose. They can try to build a package that includes an incentive on those insulation measures. And if it screens out as a cost-effective evaluation, which consumers don't really see that, but the software we use actually models energy savings based on the home configuration and your actual energy use bills. If they can put together a cost-effective insulation package, then they'll come back to the customer or the homeowner and offer that in addition to the free work they've already done. So it becomes an option where we're because we have a new software that's modeling the energy savings, we can go deeper on homes that didn't used to be cost effective. So we're finding ways to glean more cost effective projects out of the program because we can actually model the energy savings. So that's the long and the short of it. But if
so the good news there is that even if you don't qualify for home energy performance, it's still worth going through that home heating index calculator.
Absolutely.
And getting the free air sealing. And it's a great innovation, because I know in previous button ups there's kind of a lot of frustration. We have frugal Yankees who leave their thermostat at 60 degrees or something like that and don't qualify with the home heating index. But now there's another means for those people.
So is the entry point the same for the regular program and the light? You go through the New Hampshire Saves and the heating index calculator?
Yep.
Okay.
The only difference is that we're kind of accepting all applications at this point. It's just that the ones that come in with a home heating index of 7 or higher automatically qualify for the program, where the auditor might not actually install things when they're there the first time, but they'll give you the full proposal, where the light program, the auditors treat it as if it might be the only time they're in that home, and they might just do whatever they can do while they're there. So it's not a diminished program, but I will say that homes that qualify with a lower home heating index generally don't have as much opportunity. So things like basement wall insulation might not qualify for incentives, but attic insulation might. But
the other caveat is that if you're not with Eversource right now, this is only a program that's offered through Eversource.
We're hoping to make it work, and we'll see how the other utilities feel about it once we kind of pilot it this first year and see how it goes.
So this is just an example of work that was done in a house where they got the $6,000, kind of maxed out that $6,000 rebate, but they did get air sealing for at 100% utility cost share, and that's with the regular program. And got a lot of work done. It was a $10,000 job, and the homeowner only had to pay a little over $4,000. So lots of good examples like that out there. And that included also the energy audit and everything. So I know we're getting pretty close to 8 o'clock. I'm just about at the end. I've got 3 slides about the Inflation Reduction Act and some of the programs that are coming down the pike with that, as well as the existing tax credits. But I also want to mention that there's the Weatherization Assistance Program and the companion Home Energy Assistance Program through the utilities, Weatherization Assistance through New Hampshire Department of Energy and the community action agencies. So these are income qualified programs and very similar type of weatherization work, but it's particularly for people who are on fuel assistance and whatnot. And the nice thing about those is that there's no cost whatsoever in those weatherization improvements. And sometimes there can be additional work like health and safety work, things like that can be done. So important to keep that in mind for those who qualify for those programs. And so I know we're about at 8 o'clock. Is everybody okay with got these 3 slides before we get to the end about the Inflation Reduction Act, tax credits, and home energy rebate programs that are the tax credits are happening now. And so, for example, if you're getting weatherization and you've got cost share with utilities, home energy performance program that's up to $1,200, you can be getting actually it's a 30% tax credit up to $1,200. So you can be getting 30% tax credit on the part that you do have to pay for. There's a number of DOE, US Department of Energy criteria with these, but notice that a heat pump hot water heater, you can get a tax credit. It's a 30% tax credit, but it's up to $2,000. That all these tax credits are on top of whatever New Hampshire Saves incentives that you can get. So you can kind of double up there. And then in addition to that, either the home electrification and appliance rebates or the home efficiency rebates, those can be in addition to the tax credits as well. They have to be either or, the HERE program, home electrification appliance, or home efficiency rebates, but those are in addition to the tax credits as well as New Hampshire Saves incentives. So the home electrification and appliance rebates, it's associated with this area mean income number, and that is, for example, the 80% level is about $96,000 for a family of 4. The family of 4 for 150% of area mean income was about $188,000, I think. So it depends on those income levels of what you can get. The HERE program isn't available for people who are over the 150% of the area mean income. But this is a great program. It's not there yet. It's in the works with New Hampshire Department of Energy administrating it. It's federal money that flows through New Hampshire Department of Energy. And again, this is on top of the tax credits and on top of whatever incentives you can get from New Hampshire Saves. And you may choose instead to go through, rather than the HERE program, electrification, the home energy rebates, which is actually very similar to the home energy performance with New Hampshire Saves and on top of. And this one's got a under 80% area mean income or everybody else. And so the rebate level is either 80% or 50%. And then it has some maximum amounts depending on how much the energy savings are going to be. And the state is still in the process of deciding whether that would be modeled or predicted energy savings or actual energy savings. But either way, with these 2 rebate programs, home efficiency rebates or home electrification appliance rebates, these are upfront rebates that you get. And that's on top of the tax credits that you would claim the following tax year with your taxes. So there's some kind of exciting with all these new programs that are coming down the pike, in addition to the New Hampshire Saves programs. And that is pretty much it. We're a little bit after 8, but I'd be glad to stick around to answer more detailed questions. Like I mentioned, a copy of PDF of the presentation is available from the Plymouth Area Renewable Energy Initiative. And then I'll leave my slide up with my contact information, both at Lakes Region Community College as well as the other work that I do. But thanks a lot. Thanks for coming out on this snowy day. And I'm going to stop the slideshow, at least part of it, and you'll still see the um, my contact information there. So anybody have any questions either for me or Phil, um, or any comments about material that covered, or have you gone through any of these programs or had a blower door test or things like that that you'd like to mention to the rest of the group?
And I don't see any questions yet in the chat. I did have one. I was wondering what a infrared camera cost. Does it make sense for like an energy committee to try to purchase one of those and help people in their town look at leaks in
There've
their
been
house and
some,
hear it?
yeah, some energy committees have done some things like that. There are little infrared camera attachments you can get on smartphones, and that's the most cost-effective way to get an infrared camera. And those start at around $300. A little bit better ones are more like $500. And they're not bad. They're not as good as a $1,500 professional infrared camera. But yeah, they're fairly expensive. Um, there's some talk about the Max Makerspace in Peterborough having equipment that people who are qualified to use them. So maybe there'd be like a little training. You know, the challenge with infrared camera is that it can provide some real interesting information, but um, there's a lot of other things that can kind of get in the way of giving you information that's easy to interpret with it. For example, if you've got, say, for a radiator or a baseboard heater that's on a wall, that's going to heat up that wall and sort of mask what might be going on with insulation or lack of insulation in that wall, or the effect of sunlight, or the fact that some materials are more thermally reflective, like glass or metal, than other materials, even some types of paint. So it gets a little bit tricky. I always caution energy professionals to, before they go out and use infrared camera a lot, to go and get some training, because it is a little bit technical when it comes to understanding what's going on, looking at that infrared image. But on the other hand, you know, they can be very easy just to kind of point and shoot at surfaces, and sometimes somebody without much training can still kind of find out where they might have areas of missing insulation, things like that. I think a blower door would be even better tool to figure out a loan program for, and there's some discussion about doing that with the Peterborough
Everybody.
Renewable Energy Project, and they've got this big program, Harrisville and Peterborough, to weatherize a lot of homes and to train people and to get people kind of more involved in moving towards net zero energy for the whole community. So I hope people will see kind of more things happening along those lines.
Andy, if I can jump in, I do think, from my experience, the $300 or $400 smartphone attachment cameras, they're not bad. I mean, I think the one that I bought recently has the same resolution as the $6,000 model that I used, 15 years ago. So, they're not the state of the art in terms of resolution, but they're functional. But the other thing I was going to add to what Andy pointed out is that oftentimes where an IR camera is useful is seeing infiltration. And it's hard to do that without depressurizing a house. Now, if you know what you're doing, you can create, a situation where you're depressurizing the house to pull airflow through the building shell. But it's easier to do with a blower door running.
And what I'm going to do, I think, is stop the recording here unless you want me to keep on going with it. Does that make
Oh, I think
sense?
just the only thing I'd like to get on the recording is, the prep team in Peterborough is very much on top of what's happening with the IRA money and some of the things that Andy talked about tonight. So I will be in contact with them and get them to come and do another presentation for all of you again in Nelson and Sullivan. So I'm not sure when that will be. It's probably going to be more towards when the IRA money starts really becoming available.
Yep.
So they're getting trained to do that. So
Yeah, and you can go to the New Hampshire Department of Energy, and they have two different web pages, one for that home efficiency rebates, and the other one for the um, home electrification appliance rebates, and they have some information about that. And then there's also, I think there's been some opportunities, there'll probably be more opportunities in the future to comment about those programs because they're still very much in the works about how exactly they're going to get implemented. But from what I hear from New Hampshire Department of Energy, they're aiming for a later part of this year to start implementing those programs. Be great to see the utilities kind of involved with the implementation, but then it's still to be determined exactly who's going to be implementing them on behalf of the New Hampshire Department of Energy.
I agree, Andy. I think I'm optimistic that the New Hampshire DOE will come forward with the program. In addition, some of that IRA money did go to state departments of energy, which are we got some, but the IRS also has tax credits available to folks. So there's an energy improvement or energy efficiency home tax credit. There's a residential clean energy credit. And I think, things like renewable generation, EV charging, even electrical upgrades to support EV charging and solar PV is now deductible at 30% of the rate of the cost, which is a
The
significant.
tax credits I talked about were just mainly on the efficiency side of things, but for example, wood stoves, solar PV, and then kind of interestingly, the ground source or geothermal heat pumps all count for those 30% tax credits. But
The other thing that I've been surprised about, Andy, and it may not make much sense for anybody except co-op members, but at this point, but battery storage is part of that 30%, and the co-op has a time of use net meter rate where if you have solar, you can charge your batteries during the day, and then you can dump your batteries from 4 to 8 when the rates are higher. There's a higher export rate at that point in the day. So they're being proactive about, trying to get the generation to the grid when it's most valuable, which is kind of interesting.
yeah, there's the kind of a big push with all that, and it's nice to see that 30% tax credit can include the battery storage with solar.
Yep.
So good time to stop the recording, or should I keep it going a little longer?
Thank you very, very much. That's all. I just wanted to make sure that I got on. Thank you. Appreciate all of the presentations and everybody that attended. Thanks so much.